Let us look at an experiment to show how the graph of enthalpy of neutralization can be drawn. You are provided with solution B, that is 1 molar nitric 5 acid and solution X, that is 1 molar sodium hydroxide. You are required to determine heat of reaction, per mole of B using the procedure below. So procedure, fill the burette with solution B, using measuring cylinder. Put 20 cubic centimeters of solution X into a plastic beaker provided. Add 4 cubic centimeters of solution B from the burette and determine the highest temperature attained. Continue adding four cubic centimeters of B, and every time determine the highest temperature attained. Fill the highest temperature attained in the table below. Now we have a table. So we have 4, 8, 12, 16 addition, 24, 28, 32. So this is for volume over solution B then temperature obtained in degrees Celsius. So 4, 8, 16 cubic, 20, 24, 28, 32. The temperature at those different additions. The first one is 19.0. There has to be a trend of decimal. 20.5. Then we can have 21.5, 23.5. Before that you can have 22.5, 23.5, 23.0, 21.0, and finally 19.0. Back to the starting temperature. We want to use this data to draw a graph, and that graph will be the one to represent all the enthalpy of neutralization graphs. Just the trend, or rather the way in which those graphs should be. So before the graph, this is the kind of experiment that we are going to have in different additions as we try to measure the temperature. Then we'll have question 1, that is plot a graph over solution B used against as temperature. Of solution attained. So the graph should have a grid. Then it is important to note that we are plotting the temperature against the volume. So this is the grid that you're going to use to plot that graph. So the grid must fit the space that you want to use to plot the graph. So let's say we have this as our grid. x-axis and y-axis as usual. That is the y-axis, the x-axis, sorry. Then we have the y-axis. So that is our y-axis. Plot the graph. We have from 19 to highest of around 23.5. 5 can help. 1 2 3 4 5. So that is 5.0, 10.0, 15, then 20. Then the volume, we can use 4 4. 1 2 3 4 5. So we can have 4, 8, 12. That will be less. 16 will not be enough, because we have to use what will fit everything. So we have this as 8, 16, 4, 12, 20, 24, 28, 32. That will fit all that we want. So it's not starting from 0, so that is broken. Then we plot. There is 419. 4 and 19. Then we have 8, 20.5. Then there is 12, 21.5. That line. Then we have 16, 22.5. Same line. Then we have 20, 23.5. Here that's a 23.5. Then there is 28, 21, 24, 23. Already there is a drop. 28, 21 is already dropping. 20, 32 coming down to the starting point, and 32 is going all the way to 19. So we want to get this good starting point of the curve as well. Not the curve, but the graph. So these are well plotted. Then we have the back line, the one that is dropping. Thereafter, there is extrapolation. So this is extrapolated to obtain the maximum temperature value. So we want to use that graph. There has to be extrapolation so that we are able to know the highest temperature. As you can see, our graph is now giving us the highest temperature. Good. Next question, determine, that is part B, determine the volume of solution B. That reacts completely with solution X. From the graph, that is exactly 22.0 cubic centimeters. From the graph, another question, determine the initial temperature of solution B. And that is down before the start, giving us about 18.5 degrees Celsius. We can also use that to answer some other question, like knowing the temperature change when the solution is completely reacted with another solution. Thereafter, we can go ahead and determine the heat that is evolved when the reaction is complete. Finally, we can use that to determine the heat of reaction per mole, what is called molar heat of neutralization, for the full reaction between solution B and solution X. So determine the volume of solution B that reacted completely. So that volume is exactly what we have said is 22.0 cubic centimeters. Then the other question that we mentioned is determine from the graph, determine the initial temperature, and that is